Here we have an interesting logarithmic expression, which was requested by a fan of Ho's Academy. The expression looks complex, being a multiplication of a long series of logs beginning from log base 64 of 63 over to 63 of 62, and so on until you reach base 2. If you want to attempt this question on your own first, you should probably do so now. Alright, so while I can't guarantee a question like this might be on your IB exams, working through this question might help you with use cases and realizing how to use the change of base logarithm rule. So what is the change of base rule? So let's say you have a logarithm, base b, argument x. You can change this to any base you want, let's call it c, divided by the same logarithm base with the base in the argument. So the way I remember this is that the bottom would go to the bottom and the top would go to the top. And with this, you can create new expressions or with this fraction. But you have to remember that this is not the same as subtracting two logarithms. Which would result in, this would result in. As you can notice, the logarithm here is outside as opposed to here, where the logarithm applies to the entire fraction. So don't make that mistake. So how can change of base be used to solve this question? So if you notice that the base of this logarithm corresponds to the argument of this logarithm, the base of this logarithm corresponds to the argument of this logarithm, and so on, all the way down to log base 2 of 3. So you can use the change of base rule, and there'll be some terms that can cancel out. So log base 63 of 64. You can split this up into, well, let's use the natural log. Natural log of 64 over natural log of 63. Now, there's no particular reason why I'm using the natural log. This is just a choice to make it easy to read. So in the original expression, we would have times here. Times. Let's do the natural log of 63 over the natural log of 62. And we'll continue this one more time. The natural log of 62 over the natural log of 61. And let's put dot dot dot. This represents the rest of the terms. So straight away, we'll see that these terms can cancel out. If you look here, log base ln of 63 cancels here because this numerator multiplies into the denominator and cancels out. 62 cancels, and this would continue on and on until you only have natural log of 64 over natural log of 2. So using the change of base rule again, we can rewrite this as log base 2 of 64. We know that 64 is the same as 2 to the 6th power. You can verify this really quickly. 64. It should be the 6th number. Yep. And using the logarithm power coefficient rule, you can bring this to the front. 6 times log base 2 of 2 is the evaluated answer. And we know that log base 2 of 2 is just 1. So your answer will be 6.